And we have a right cylinder and we have an oblique cylinder. A right cylinder will be straight up and down. The height or the altitude will be perpendicular to the base. But an oblique one is slanted. The height, or this piece right here, is not perpendicular to the base. And so since this piece right here is not perpendicular to the base, then we call it oblique. Okay, so these guys are cylinders. So let me write this up here. And just a basic definition of your cylinder, it's a solid that has two parallel congruent circular bases. So this is the base, this is the base. They are parallel and they are circular bases. In the oblique one, this is a base, this is a base. They are parallel and they are congruent. And they are circular. Okay, pointing at this piece right here. Anybody know what I can call it?
The height.
It's the height, it's the altitude. Okay, anybody know about this little piece down here? What's this guy? Yeah, it's a radius. This is our circle, and that's the radius of the circle. After we get done exploring this unit, this unit is basically just looking at shapes, not doing much with the shapes. After we're done with this unit, we go into volume and surface area of these shapes. Okay, looking at this picture, this right here, what would you say that is? It's the height. We can also call it the altitude. Okay, and then we have an arrow pointing to this guy right here. What's this guy right here? Radius. Okay, and then this one is not the height because it's not straight up and down, and they just call it the axis. So it's not straight up and down, so it's not the height, it's not the altitude, it's just called the axis. Okay, does anybody need to see the net again? We looked at this net yesterday. Does anybody need to see the cylinder unrolled again? Are we good? It's made up of what?
A rectangle and 2 circles.
2 circles and a rectangle. So I'm just going to put here that it's made up of 2 circles and 1 rectangle. So that's what its net looks like. That's what it looks like when you unfold it. It's made up of 2 circles and 1 rectangle. Okay, these guys down below, what are they? They're cones. And so we have a right cone and we have an oblique cone. So the right cone just means that the height is perpendicular to the base, and an oblique one is slanted. And so that's because this piece right here that starts at the vertex of the cone down to this is not perpendicular to the base, and so that's why it's oblique. It's slanted. Okay, this guy up here. Any idea what we might call that? The vertex. That's the vertex of the cone. That's where the pieces come together. Okay, how about this arrow right here? It's the height or the altitude. Okay, and then how about this one down here? Radius. Okay, and then in the oblique cone, what would this right here be? The height or the altitude. Height, altitude mean the same thing, and they do have to be straight up and down, perpendicular to the base. Okay. Everybody got that? Okay, moving to the next page. We have a what? A sphere. So our sphere is a set of all points in space that are equidistant from a given point. And this guy right here is called the center of the sphere. And this over here would be called the radius of the sphere. And And then this one we saw in our little video that we watched the other day. This is half of a sphere, so it's called a hemisphere or a hemisphere, however you want to say that. So once again, this is still the center. And this guy right here is the radius. So like if you think of the Earth, there's the northern hemisphere and the southern hemisphere, and that's because that's where they divide along the equator. This circle, if you ever have half a sphere, this circle right here is called a great circle. Okay, we're just going to answer a few questions. All right, looking at the guided practice, it says name the basic components of the 3 curved solids. Let's start with the sphere just because I happen to be on the page with the sphere. So what were the 2 things that we mainly named in the sphere? The center and the radius. So those are the basic components that we need to know for the radius. Okay, if you flip back and you look at the cone, what kind of things did we name for the cone?
Height, vertex, and
Mm-hmm.
radius.
The height, the vertex, and the radius, or altitude, vertex, and radius. And the cylinder, if you look back at the cylinder, what were some of the things that we wrote about it?
Height, radius, and axis.
Mm-hmm. The height, the radius, and then we also had that axis in there. Okay, number 2 says, what defining shape do all curved solids contain? What do all of these contain?
A radius.
Mm-hmm. But what defining shape?
Oh, a circle.
Yeah, they all have a circle. Okay, and then number 3 says, study the figures below. Do they represent cylinders? Explain your reasoning using the definition of a cylinder. So I'm just going to go back to the definition of a cylinder real quick. A cylinder has 2 parallel congruent circular bases. That's the basic definition of a cylinder. It has 2 parallel congruent circular bases. So would you say this first one here has 2 parallel congruent circular bases?
Yeah.
The problem is they're not full circles. That's the problem. So I would have to say that this is not a cylinder, and that's because these are not full circles. But that's the reason. If these would be full circles, then I would have it. And I'm just going to say not a cylinder, not full circles. They're just semicircles, or half a circle. What do you think about the other picture? No. What's the problem with this one?
The circles don't match.
They are parallel, but they're not congruent. So this isn't, I'll just put a no. And I'm just going to say bases aren't congruent. So bases aren't congruent. So to be a cylinder, your bases have to be parallel and they have to be congruent circles. All right, I just want to think about number 4 for a second. This says, what would a prism with a 100-gone base look like? Let's just answer that part right there. What would a prism with a 100-gone base look like? Any idea? So we've got a prism. Let me see what prisms I have in here. Okay, so I have my triangular prism that has triangles for bases. Of course, the sides are rectangles. My other prism, let's see here. Okay, I guess those are the same. This one is a hexagonal prism because the bases are hexagons and all the sides are rectangles. This is saying what would happen if a prism had 100 sides to its base. What do you think you might end up with?
A cylinder.
A cylinder. The more and more sides that you have here, the more circular this is going to look. And I don't know, I mean, I only have these two to compare, but this doesn't look very circular. Is this starting to look a little more circular? That's because it has more sides to it. So if you can imagine going from 6 sides on the base to 100 sides on the base, this would look more and more like a circle. And if this looked more and more like a circle, then this would look like a cylinder. So that's what we really want to have here. It would look like a cylinder. Oh, your picture didn't even come out for this. On the next one. In this second question here, how is a cylinder a special case of a prism? That's really how a cylinder is a special case of a prism. It's a prism with like an infinite number of sides for its base. Okay, this picture didn't get put on your paper here, so I'll just talk about it just for a minute. Do you guys do much in any of your classes with longitude and latitude? Do you do much with it? Okay, so these right here, the longitude, just so you know, the longitude goes through the north and the south poles, and the latitude, it goes through the equator. And then one of the questions up there asks, how many times do the longitude and the latitude intersect?
4 times. 5, I don't know. 5, 6.
Can you tell how many times they intersect?
7.
2 times.
It's just 2.
No, what is this little dotted line say?
Where are they, Andrew? Come point to them.
I have to point to them?
Yeah, come point to them.
Okay.
It's your day to shine. Here, you can point with my marker.
Oh, yeah?
I get out my pointer, but it's
Right
gone and missing.
there.
Where?
Right there.
Right there? Where's the other one?
Right there. Yeah.
Those two, right there and right there? Do you guys agree? Can someone else? It is 2. Can someone else point to the 2? Does anybody else know where the 2 are? Come point, Craig. You can use my marker. Right there, right there. Bing, bing. Right there, right there. That's where the longitude and the latitude intersect. Are those 2 spots right there, and they do intersect twice. Okay, so I want to go to this. I don't want to have any homework. I want you guys to take a few minutes and try to answer these questions, and then we're going to go over them, and then you guys can just relax the rest of the class. In these right here, we're going to try to figure out these real objects, what kind of a 3-dimensional solid figure can I name that they would go with? And so we do want something 3D. We do want something 3-dimensional, something that does have some dimension to it. So just for example, I'll do A with you. If you talk about this real object, the tombs of Egyptian rulers, what 3-dimensional solid figure would you say that that would be?
Square pyramid.
A square pyramid. Okay, so for all of these, I do want some 3-dimensional solid figure that we've been talking about lately. Think about all of these shapes having some dimension to them. They're not just going to be a rectangle. They're not just going to be an octagon. They're going to have some dimension to them. So see if you can figure out the B through the L. And then I also want you to try 2. 2 is asking about true or false. So take, I don't know, 5-10 minutes. Try those, and then we'll go over them. And if any of you don't know what the cell of a honeycomb looks like, get out your phone and Google it. I don't care. So take a few minutes and see what you think for this, and then we'll go over them.